Hello, I'm Natalie Rhea. Today I'll be discussing Lab 3, examining the magnetic field of a bar magnet. The objectives of this lab include measuring the magnetic field generated from a bar magnet using a smartphone, determining the relationship between the generated magnetic field and the distance from the magnet to the smartphone sensor, and modeling the magnetic field system with Glowscript. The first important principle in this lab is the Biot-Savart law, which describes the magnetic field generated by a constant electric current. Specifically, we will be using the expression for magnetic field B created by a dipole with magnetic moment theta naught at an observation location R relative to the magnetic dipole. Another important concept is the distance-dependent nature of a magnetic field. The magnitude of magnetic field B is proportional to the distance from the magnet to the observation location. The magnitude of B decreases as distance increases, so n is negative. First, I will describe the experimental setup and data collection procedure. To begin, we oriented the phone to compensate for magnetic north by placing the phone so that the x component of the measured magnetic field was nearly 0 microtesla. Then, to make sure that there were not any major interfering magnetic fields nearby, we checked that the net magnetic field was about 49 microtesla to match the Earth's net magnetic field in Atlanta. Then we taped a ruler along the bottom of the phone. The ruler demarked the east-west axis. Next, the location of the magnetic sensor inside the phone was located by finding the positions along the length and width of the phone where Bx was at a maximum when placed near the bar magnet and slid in a given direction. The sensor location was marked with pieces of tape over the phone. Once the ruler and magnet were in place, we conducted 3 trials to measure the distance r from the magnet to the sensor that resulted in a Bx of 20 microtesla. We then repeated this process for Bx's of 70, 120, 170, and 220 microtesla. We recorded the distances in Bx values and plotted them in the graph shown. Next, we found the distance, labeled as d_perp, required to produce a Bx of 100 microtesla. This distance was about 17 centimeters. We then moved the phone up the same distance so that the sensor was placed at a 45-degree angle from the sensor and recorded magnetic field values in this position. Now let's interpret and make some calculations with the collected data. The slope of our graph from the on-axis part of the experiment was negative 2.9259, and this value is n in the distance dependence relationship. This value is expected to be near negative 3 to reflect the fact that magnetic field is proportional to 1 over r cubed in the Biot-Savart law. The y-intercept of the graph represents the natural log of k, so we can calculate the value of k as shown. Next, we can calculate the magnetic dipole moment by rearranging the Biot-Savart law and the distance dependence equation to solve for mu. I found my magnetic dipole moment to be 2.87 ampere square meters. Lastly, I will show my Glowscript model of the magnetic field system. First in the code, I created a cylinder to represent the bar magnet. Then I initialized a few key values, including the mu we just calculated, and I defined a function to calculate the magnetic field when given a magnetic dipole moment and a distance. Next, I created 2 arrows to represent the on-axis magnetic field. Then I created 4 arrows perpendicular to the magnet to represent the off-axis magnetic field. And lastly, I created an arrow 45 degrees to the axis of the magnetic dipole. Here is the resulting Glowscript model and the computer calculated magnetic field values. The Glowscript computed magnetic field values are quite different to those collected, most likely due to magnetic interference and human errors while collecting the data. Discussion question 1. What if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? The measurements for the x value of the magnetic field would have been inaccurate. There would have either been a positive or negative value added to the measured Bx coming from the Earth's magnetic field, and this would have affected the calculated n, mu, and k values. Discussion question 2. What if you were to stick 2 identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? The magnitude of the magnetic field would approximately double, the direction of the observed field would be the same, and the magnet would not have to be brought as close to the sensor to produce the same magnetic field readings as with one magnet. That's all for this lab. Thanks for watching.